It's my pleasure to introduce John Purcell, who's director of the Chicago Downtown Office of the U.S. Department of Energy. John Purcell has his B.S. in mechanical engineering from the Illinois Institute of Technology. He has a broad government experience in the area of energy application. He has been project engineer on a national solar demonstration program, and presently his office is responsible for the technology transfer and outreach programs in the Midwest. John is going to talk to us today about the national energy picture. John Purcell.
Thank you very much. Can you hear me? Should I pull this thing up a little higher? It's a pleasure to be here this morning on such a beautiful day with the sun shining, solar collectors working. I appreciate those remarks by Mr. Sorrells, and I certainly hope that the federal and state governments can work together in the future. Politics be damned, we need to work together. I think that we need an energy policy and we need an energy plan, and we've got to work together with the federal, the state, and the private sectors, because I certainly agree with you. It's a very serious problem, a serious question that needs to be addressed, and addressed soon. Although I'm going to talk on a little lighter vein than that. That's awfully heavy stuff, you know what I mean? Although I agree with that, it's certainly a heavy picture, and but let's talk about solar energy. It's a much brighter, lighter thing. I think on a rainy day we've got to pick up our spirits and look to the brighter side a little bit here. Anyway, let me give you a little background here. On October 26, 1974, the Solar Energy Research, Development, and Demonstration Act was signed into law, authorizing the federal program of research, development, and demonstration to establish solar energy as a viable energy resource for the nation. The program planning of solar energy research, development, and demonstration is being carried out under the guidelines established by this act and by 3 other legislative acts passed by the 93rd Congress. The Solar Heating and Cooling Demonstration Act of 1974, the Energy Reorganization Act of 1974, and the Federal Non-Nuclear Energy Research and Development Act of 1974. Together, the 4 laws give general authority to the Department of Energy and other federal agencies to conduct a wide range of activities as part of a research, development, and demonstration program aimed at effective energy utilization. So that gives you some general background. As you know, DOE supports different solar programs. There's the National Program for Solar Heating and Cooling of Buildings, the Solar Thermal Energy Conversion work, Photovoltaic Energy Systems, and Ocean Thermal Energy Conversion. So there's kind of general categories. Are we going to have a slide?
Excuse me, just go ahead and say.
Oh.
It'll come on.
Okay, great.
Sure. There you go.
Oops. Okay, can I have that first slide? This is the period when you need faith. Okay, I want to touch on each one of those general areas of solar energy, and I'll come back to the heating and cooling of buildings. But have the next slide? Oh, there's a button here, sorry. Power generation from solar energy is in the beginning stages. You can see here, this is a power tower. The primary focus is on central receiver concept. A 10 megawatt pilot plant is scheduled to begin generating electricity by the end of 1981. We plan to initiate preliminary designs in 1979 on a 100 megawatt demonstration plant to become operational in 1985. Associated with the 10 megawatt plant is the construction of a 5 megawatt solar thermal test facility. This facility is located in Albuquerque, New Mexico, and is operational now. The principles involved in the photovoltaic are well known, and as we know, experience has been gained through the space program. We need development of less expensive cells, and we need more people producing those cells. The major problems to be overcome, obviously, are high cost and low production of these cells. The cells cost about $15,000 per peak kilowatt. We're hoping to, we have a program of producing less expensive cells by improving the efficiency and coming up with new manufacturing techniques. We hope to reduce it to $2,000 per peak kilowatt by 1978, and we have a plan to reduce it to $1,000 per peak kilowatt in 1980, and down to $250 per peak kilowatt by 1986, which would be competitive with today's energy picture. Now, this is a very exciting aspect. It would be a tremendous boon to all of us if we could come up with a development of photovoltaics. Wind energy systems have been in use for many centuries and are known to be technically feasible. The general objective of DOE wind energy program is to advance the technology. We have a 100 kilowatt system which is being tested in Sandusky, Ohio, and that's the one pictured there, and plan to test 4 large experimental wind turbines during 78 and 79. The first 2 machines are based on the Sandusky prototype. They will have blades of 125 feet in diameter and generate 200 kilowatts in winds of 19 miles per hour. The second 2 will have blades in diameter of 200 feet and generate 1,500 kilowatts in 22 mile per hour winds. This is a conceptual picture of the ocean thermal conversion system, OTEC, and the conversion of large amounts of heat naturally collected and stored in the ocean are to be converted in usable forms of energy. You just take advantage of the fact that the solar heats up the surface of the ocean, and by taking advantage of that small delta T, change in temperature of 36 degrees roughly between the surface and 1,500 feet down, we hope to generate electricity with an ammonia system. Obviously, this type of system requires large volumes of water and a development of those heat exchanger systems. So that this is still in the development stages. We're starting to test some of the components now. Currently, over 300 companies offer solar energy systems, subsystems, and components. It is estimated they are capable of producing 8 to 10 million square feet of collector per year. And I have a figure for 1976 that 4 million square feet of collectors were sold for about 1,000 separate installations, and that has multiplied quite a bit. I think we're going to hear a little bit more about that later in the day. The federal programs are aimed at stimulating industry to an annual manufacturing and installation capability of 20 million or more square feet by the year 1980. As part of the solar energy research, development, and demonstration, DOE is conducting a national program for solar heating and cooling of buildings with the assistance of the Department of Housing and Urban Development, HUD, National Aeronautics and Space Administration, NASA, the Department of Defense, DOD, the National Bureau of Standards, NBS, and other federal agencies. The program of solar heating and cooling a building is structured to stimulate solar energy applications so that solar energy could provide at least 10% of these heating and cooling energy requirements by the year 2000. might note that only looking for 10%, which is not, on the overall energy picture, that is not going to save us. It's going to certainly help, but it's not going to save the energy picture, and that's in the future. Just to give you an idea who's involved, who the players are in the solar heating and cooling of buildings, these are the responsibilities. On the residential demonstration, that's HUD, along with DOE. The commercial demonstration, that's the Department of Energy. Development and support of demonstration is NASA. Research and development is DOE. Data collection, evaluation, and dissemination is DOE, NASA, and HUD. Standards and criteria is NBS in support of DOE and HUD. And environmental and research assessment is DOE. Under the commercial demonstration program is a program to demonstrate solar heating and cooling in federal buildings. A point that was brought up by Mr. Sorrells. The federal government, with its large inventory of buildings, has an opportunity to expand the base of residential and commercial buildings using solar energy on a cost-effective basis. This is the Saginaw, Michigan building. It's a federal building that is heated and cooled with solar energy. Those are the collectors. They're Owens type high-efficiency collectors. The one that I had on the screen before was the standard flat plate collector, which is, of course, the low efficiency, produces lower temperatures. These vacuum tube type collectors can produce higher temperature water and therefore can run the absorbing air conditioning system. That's a close-up view of the collector tubes that are used in the Saginaw facility. That's a storage tank. The size of the pump, just to give you an idea of this facility. That's the absorber. The energy, the energy is used to separate the water from a salt, and then when you recombine the salt with the water, you get a cooling effect, and that's the system that's used at Saginaw. That's a data collection computing system that sends the system over the telephone to our data collection facility. I won't talk about the data collection. I think that's obvious. I want to go on to the commercial demonstration application. The commercial building application is a major element in the program of solar heating and cooling of buildings. Like the residential, it's being carried out in annual cycles to take advantage of the technology from cycle to cycle. Phase 1 or cycle 1 was begun by National Bureau of Standards and carried out by IRTA when IRTA was formed. The solicitation of the first cycle was made in September 1975. The solicitation for a demonstration program is being done through the Program Opportunity Notice, PON. The response to the first PON resulted in 308 proposals, of which 32 contract awards were made. Solicitation for the second cycle commercial demonstration projects was released in October 1976. The selection of successful proposers was announced May 10, 1977. There were 307 proposers, from which 80 were selected. These projects include such buildings as offices, schools, hotels, motels, fire stations, police stations, hospitals, and libraries in 33 different states. The $12,600,000 were allocated for the second cycle, and I think it was $9 million for the third cycle. The third cycle was offered in November, last November, and those proposals are right now being evaluated at Argonne National Laboratory. These are some of the facilities that, I don't have pictures of all the facilities, but these are some of our commercial facilities that are part of the demonstration heating and cooling of buildings. Keep in mind that by commercial we mean anything that isn't residential. Residential is HUD. This is a scattergood school in Iowa. This is the town school in Atlanta, Georgia. Those are the collectors on that school. This is a school in Lynchburg, Virginia. This is the Grover Cleveland High School in Boston. I know somebody pointed it up as an example of bad architecture because it doesn't really, those collectors certainly don't fit into the way the rest of the community looks. This is a medical center in Wichita, Kansas with vertical collectors. And this is the University of Minnesota bookstore. This is in the design stages. That's on a model, picture of a model. This is a map that was that really is not exactly up to date, but it gives you an idea of the cross-section, or that the fact that we do have projects all across the United States. That's all the slides I have. Can I have the lights? A couple of things I want to just mention before we go on, and that is a note about passive solar energy. Just to make it clear, passive, I suppose we ought to define passive. Passive is the just taking advantage of the sun with no mechanical movement of air or water systems. And a lot of proponents of the passive side of solar, as opposed to putting mechanical systems in, has said that the Department of Energy should really do more about demonstrating this and putting R&D dollars behind it. And we in the Department of Energy are becoming more responsive to that question. In 1977, $300,000 were allocated to this directly, to passive solar energy. And in '78, it was $1.4 million. And that's direct dollars. Obviously, when, a conference like this touches on solar. When you're talking about architecture, you're certainly talking about using solar energy as a tool of the designer, as well as any other tool that he has available to him. This summer, HUD is going out with a passive solar initiative on a demonstration, for demonstration projects. And in DOE, we're planning a commercial demonstration initiative, and we don't have any dates or any firm plans on it, but that's in the planning stages, so that on the commercial side, we're going to have an initiative to demonstrate passive solar. Also, we're preparing a passive solar energy development plan to show where we're going in the general area of passive solar. So I think that in general, I want to just say that I think we're using the federal buildings as part of the solar energy program. In both, we want to include passive design as well as active design where it's feasible. I think that to put on solar energy on every facility, blindly would be a mistake. Also, just as if you push solar to the point where you want to put solar on everything and get everybody to put solar on their house, and then they become very disenchanted, and you get all sorts of people in the business that are putting up solar that is not maybe applicable, does not look good, and especially doesn't work very well. It seemed like that would be a big mistake. I think that the way I like to look at solar energy is that basically the architect should look at solar as one of his tools, just as he has any other tool. And if the active solar systems are applicable and can be shown to be economically feasible and can be sold to the client, then I think that that's when you should be putting active systems on the line. But basically, certainly we would hope that that the passive system, just take advantage of the sun with the orientation of the house on the lot and the overhangs and massive fireplaces and slabs and et cetera to collect the heat. These type of things to be included would certainly be, in my opinion, a standard kind of a consideration by an architect, and should be done, and that's what we would hope that you would be doing. Another point that I want to make is that it has been stated on several occasions that architects have very little to do with the design of buildings, and that especially individual residential homes, the average guy can't afford an architect, or an architect can't afford to spend his time designing for the individual homeowner. So that we've got to impact the system. We've got to impact the builder, or the tract builder, and we've got to impact the people that do make the decisions on how these homes are designed and to take advantage of the sun. So I guess what I'm saying is I think we need the architects. If you're not involved in those major decisions on how buildings are designed, we think you ought to be, and we think that you ought to include the sun as one of your design tools. Thank you very much.